Before we get started, I want to quickly show you what's going to happen in the next few weeks because I made a little bit of changes. So today today is the week 9. We'll continue our SQL chapter, but we will finish it today. And on Wednesday, we will start NoSQL. Okay. So I'm not sure how familiar you guys are with NoSQL, but we will choose MongoDB for our practice for NoSQL. I'll talk about it before the lecture finishes again as well. So if you can, today when you go home, you can search for MongoDB and install it on your laptop, okay, so we can practice it on it. Also, don't forget homework 3 is due this Friday. And originally I have homework 4 scheduled to be due next Friday, but because our NoSQL starts a bit late, so I moved it to 2 weeks later. So that will be the 6th of November. And that will be purely on NoSQL. Okay. So that will be that. And next week, you will be scheduling, you will schedule the time with TA this week, and you will be doing demonstration with the TA on your project next week. So she will post, she will send out an email today and post a spreadsheet, so it's first come, first served. Your team can just go out and sign up the time that you can meet up with. Okay. And for more detail on the demonstration, I think we have talked about it in the project description. If you have any confusion, you can ask me as well. Okay. So that will be that. And before we end the lecture today, we'll have a quiz. So that's quiz 5. Which is really easy. I always say that. Alright, so let's get started on today's lecture. So as I said, we will finish chapter 5 today, and we will start on NoSQL on Wednesday. And just note that NoSQL actually, the material cannot be found in the textbook. So I will try to find whether there are any supplementary material for you guys to read if you want anything to read. Or we can just totally focus on the slide its own. So, let's start today's lecture. Again, I put the instances that we'll be using today on the first slide in case you want to evaluate whether our comments are correct. And before getting into new queries, I just want to quickly talk about one of the queries that most people got confused last time. So after the class last time, quite a few of you came to ask me about this query where we were trying to implement the idea of division in relational algebra. So if you recall, in this query, we were trying to find the names of sellers who have reserved all votes, which is the division in relational algebra. And I feel like maybe I didn't put it clear enough. So in the lecture, a lot of people were like, why does this make sense? Why would this work? So I put down the SQL comments right here, which is exactly the same we put last time, and I want to talk you through why it makes sense. So if you take a look at here, it's a 3 layers nested SQL query. And outside right here, we started from selecting the name of the sellers. So if you take a look at the outer part, you can think of it as the seller S such that, okay? And the not exist lead us into here, which is there's no vote B, right? Not exist. There's no vote B for the seller. Without is from here, not in, right? And then here we say without a reserved tuple showing as reserved B. Okay, so this is the way you can try to think of it if you want to interpret it into just one sentence. Okay, seller S such that there's no vote B without a reserved tuple showing as reserved B. But if you feel like how this actually works behind the scene, then we can go back to look at the conceptual evaluation for it. Okay, and then we'll go back to look at what actually happened when the query was executed. So if we go back to review the evaluation of nested query, actually the first thing it will do is to construct the cross product of the table in the from clause of the out level query. So it's like right here, but we only have one table, so we don't need the cross product. Okay, we take the rest out first, and then for each row in the cross product, while testing the condition in the where clause, we compute the subquery. Okay, so if you look at here, after knowing that part, then for each tuple, in the table, it computes the subquery. Okay? So what happened to the third layer then? Right here we say it recursively applied the process to the inner subqueries. So if you take a look at here, then again, for this query, this one is its outer query. So for each of the tuple right here, it also computes one time the inner query. So if you want to make it a bit clearer when you think of it, you can think of it as for loops, just nested for loops. Okay? So we can say for each sailor, okay, we take a tuple, and then for each boat, in the boat tuple, and then for each reserve, in the reserve tuple, right? So when we go into the most inner part, which SID are we referring to? That's exactly that for loop of that tuple S. Okay? So that's how you can think of it when you do this kind of division concept in the SQL code. Okay? So of course, when you think of it in division, it's really different because we have a total different kind of logic when we think about division. Remember when we were deriving the math behind it, it's actually really kind of different. But yeah, you can think of it this way in SQL. Okay? Yeah?
Why did we interchange the order between both sentences? Like, why was reserved the innermost query and both one query? We generally start with sailors, reserving, and both.
How would you do if it's were for sailor reserve?
I'm not clear on that.
Okay, yeah, so the idea is because we eventually want sailor that reserve all the boats. Okay, so you want to say, you want to find a sailor that he has no boats not being reserved by him. Yeah. Yeah, that's how it works. Okay, so that's for this one. And let's start some new queries today. I'm not so sure whether we worked on this one. Have we? I went back to look at it and I kind of forgot. So for this one, we're trying to find the names of sellers who are older than the oldest sellers with a rating of 10. Have we worked on this? No? Okay. So let's try it. If you need to connect to your MySQL, go ahead now. And you can think about what we would do to implement this. If you want to find the names of sellers who are older than the oldest sellers with a rating of 10. Any thoughts of what you would do first? Anyone? Or do you think we will need a nested query? Yeah. So we want to find the names of sellers who are older than the oldest sellers with a rating of 10. How about we start from finding the oldest sellers with a rating of 10? Then put that as the inner query, right? And then we have something to compare. So let's try out to put the inner query first. So what would you do to find the seller, the oldest seller with a rating of 10? Its age. The age of the oldest seller. You would definitely select the maximum of the age, right? From seller tables, right? You don't need other tables. So what's the criteria for that? Rating of 10, right? So that's that for the inner query. Okay? And go back to look at the query. We want to find the names of sellers who are older than this age. And if you recall, even though in relational algebra we kept saying, don't forget when we do aggregation, this is one type of aggregation. Doing the alpha, the output is still a table, so we can't just compare a value with the table, right? But in SQL you can, because it knows this is a single value. So we can do comparison on that value. Okay? You can just treat it as a single value. So what would you do in the outer query then? You can use this as a threshold to get the sailors you want. Okay. So if, let's say, okay, I'll put down select from where, okay, what do you think the outer query will look like? Let's say we name this S2, right, because you can't overlap the name. So inner part we use sailors and we put S, but the outer part we use S2. Okay? And we know we want the names. Okay, so we select the name, correct? How about here?
Greater than all.
Yeah, S2 dot A greater. Do we put greater than all or just greater? Because here only return one value. Okay? So actually, here we just simply have to put like that. Okay. So that's it for finding the sailors' names who are older than the older sailors with the rating. So if you take a look at slide 6, it actually has the same query, but we can do it with a different approach. So this will be the approach 1 for this query. Okay? No problem with this? So earlier it was mentioned we can use greater than all. So how will we change this when you think we can just directly use greater than all? When we compare all, it means we compare all of the tuples in the sub-query. So we actually don't need to take the maximum. Correct? So this is approach 2. Okay, if you take a look at slide 6, on approach 2, we can actually get rid of the max, so we don't do any aggregation, and we just say it's greater than all. Okay, so if you recall, we have learned about this all for the set operators. So if you put all, it means compare every single tuple in the subquery. Okay, so they will actually achieve the same answer. But one question here, which one do you think is better? Which one do you think will be faster? First one, right? Because for the first one, you actually get the maximum first, and then you only need to compare one, okay? For each tuple in the outer query, you only compare with one value. However, if you do all, then for each tuple in the outer query, you will compare with every single tuple in the subquery. Okay, so the approach 1, when we do the maximum, just simply compare with the maximum. It's a lot faster. Okay. Any question on this one? Wait a bit and we can move on to query 31. Okay, so up until now we have learned how to deal with the basics for a SQL query. But there's one concept we haven't learned yet, which is the group. Yeah. For you recall in relational algebra, right now we are able to do the alpha with only one argument, which is the one we compute like maximum, minimum, average, summation, all these things. But if you remember in relational algebra, when we have 2 arguments for the alpha, that means actually for the first argument, that's our grouping criteria. So we haven't learned anything about grouping yet. So if you look at query 31, in this query, we want to find the age of the youngest sailor for each rating level. So right now, we haven't learned about any grouping. So what would you do to solve this query if we are doing it without any group. So one of the approaches I saw in midterm 1, which is the, I think I asked you guys to write the average rating or age for each color of votes, right? The same there. So a lot of people did it in a way that will get us the correct answer, but you have a pre-assumption saying you know what are all the colors in the votes. So that's a brute force way, which is like this. So here we do select from where, same thing. And because we want to find the minimum age, right? Minimum age, that's easy. And we select from Saylor's table, we call it S, that's our range variable. So here, what I say goes, I mean, you can just do it, okay, when rating is 1. Okay, and then you move on to when rating is 2, when rating is 3, and you keep going, okay? But this one has a drawback, because if you add a new rating that's never seen before, then you can't detect it, right? This is too manual, okay? So this is the approach. You don't really have to write it down because that's not the one we want. So here I'll talk about grouping in SQL. Okay. So far we have learned select from where. Haven't learned about group by and having. So select from where, easy. We already know how to use it. Okay. So group by is the new thing that we want to introduce, which if you put the variable that you want to group based on, then you will group it into groups. For example, we can do group by, say, S.rating. Okay, then that would be group by rating. And an interesting thing right here is having. So for the having clause, it will actually, we call it the group qualification. So it's similar to where, but it's the qualification for each group. Okay? If you look at the where, it's actually the qualification for each tuple that it's selected from. Okay? So later on, we will show you how we can use having to see whether the group that you grouped out qualify. Okay? A few things to know in the target list, which we are already really familiar with, are the fields and columns that you want to keep. So when you're using GroupBy, there are a few things that you want to pay attention to. For example, for the attribute names, okay, it can contain attribute names in terms with aggregate operations. For the attribute names, it must be a subset of the grouping list. Okay, grouping list right here. I'll show you how it is later. And also the terms with aggregate operations. Okay, so the terms with aggregate operations are like minimum, maximum, average, counting, summation, all those things. Right? And if you remember when we learned about relational algebra, when we do like average something, we just assume the name will change into, for example, if we have alpha, like average age, okay, on whatever, then later on, the thing that returned, we just assume that the name will change into something like this, right? If you remember. So right here, actually the same. When you do it in SQL, it's actually the same. It will just have a name kind of like that. And sometimes it's hard to deal with names like that. You can't really control it because maybe you want it to be something else. Then you can just rename it with us. Okay, so that's really simple. All right, so that's like the renaming list in relation. Okay, so let's try out a very simple example of grouping. Okay, of the one we talked about before actually. So we want to find the age of the youngest seller for each rating level. Okay. Can you think of how we could do this? I'll get rid of this for query 30. So this is the brute force approach we were trying to solve query 31. So now we know how to do grouping. What do you think, how will we change it? Do we change any of these? They're the same, right? So right now we already know grouping. So for this query, do you think we need anything in the where clause? Right, we don't need it. Instead, we want group by what? Rating. That's it. Okay? So we want to select the minimum age of the sellers from the sellers table, where we group by the rating of the sellers. Okay. If you want to make you having more information, which makes more sense, like which rating is this minimum age from, then we can simply just add one more column. So that's like that. Okay, so this is what we mean earlier when we talked about what should the target list in here include when we use grouping. So if you recall earlier, we talked about, let me see what I put down. We say the target list should include here, which is the terms that have the aggregation, and this one, which is the attributes, subset of the attributes. Okay. Okay. You don't have to have both, but like they can only be from these two. So if we take a look at how the result will be like, okay, so this is what we will do. All right? So as you can see right here, we just simply let it have the automatic name, minimum s.age. Okay, we didn't rename it. So if you want to rename it, what you can do is actually right here. You can say name. Okay, that's it. Then you rename it. So if we go back to paste it, then we have a new name for that column. So maybe later on when we are doing nested query, you need to refer to that if it's easier to remember. So that's for that. Any questions for this one? All right. So let's take a look at query 32. Things will start to get kind of complicated. So we want to find the age of the youngest seller who is at least 18 years old for each rating level with at least 2 such sellers. So as the query goes on, it gets a bit confusing, but when we say at least 2 such sellers, it means we want the sellers to also be 18, greater than 18 years old. So what would you do for this one? We can also change it based on what we have right now. So if we read it, the very first, just the first part, saying find the age of the youngest seller who is at least 18 years old, then what are we missing right here? Do we use having or not yet because we need the 18 years old? Where, right? So right here we add a where clause saying we only want those who are at least 18 years old. Okay. So, where will we use having? When we take a look at the second half of the query, we say for each rating level, so for each rating level we have GroupBy to handle it, right? With at least 2 such sellers. This is where we want to use having. So if you do having, and we just count the number of sellers in each group, do count, okay, then at least 2, you either do greater or equal to 2 or greater than 1, doesn't matter, and that will do. So I'll leave this query comment right here, and you can take a look at slide 11 of the conceptual evaluation of what actually happens. So a very subtle difference between where and having is where is the qualification for each tuple that you select, right? Having is the qualification instead for the tuples, but for the groups, okay? So if you take a look at slide 11, we will talk about when we have grouping in the SQL commands, what's the evaluation process. So the first step is the cross product of relation list that will be computed. And again, this time we only have from sellers, so that's just one table. We don't have to take the cross product. If you look at the second step, so the tuples that fail qualification are discarded. So second step will be based on the where clause. Okay, so where clause specify what is the qualification for the tuples, okay, from the cell or table. Okay? And the third step, saying unnecessary fields are deleted, which clause are we talking about right here? Select, right? Because select, you throw away the unwanted field, unwanted columns. Okay, so that's the third step. Okay, first step we look at the from, second step we look at the where, third step we look at select. And the fourth step saying remaining tuples are partitioned into groups by the values of attributes in grouping list. Okay, so far in select from where we got the tuples we want, we got rid of the fields we don't want, and we group it by S rating. Okay, so that's what's going to happen in the fourth step. Then in the fifth step, the group qualification is then applied to eliminate some groups. So that's when you look at having and then check each group. Okay, so the criteria, or we said the qualification you can put in having is actually limited. You can't just put anything because it has to make sense when it's on a group level, okay, which we will show you later. And then the one answer tuple is generated per qualifying group. Okay, so that's the steps for that. So let's take a look at query 33. And think about, now we know the evaluation process, how we would do query 33. So for query 33, we say for each red vote, we want to find the number of reservations for this vote. What would you do? So, how many tables do you think will be involved? Two. Which two? Votes and reserves. Reason we need two is because for votes we want the color information, okay? And reserves we have the reservation information. Okay? And what are the things we want? We want, for each red vote, we find the number of reservations for this vote. So we can say, all right, we want to have the vote ID of the red vote, and we want to count something, right? We want to count how many reservations are there. And just remember, when we use this, we just make saying count all of the fields. We're not specifying which field we're counting. How about the where clause? Remember at the beginning of doing these queries, when we weren't doing anything nested, whenever we say we want to join, kind of associate two tables, what do? Something between them has to be the same. BID. So the BID in votes going to be the same with the BID as well. Okay, so that's how. Color as well. Okay, so we first join them, and on top of that, we only want the red vote. Okay, great. We only want the red vote. So in the where clause, we have two terms. The first one is for the sake of joining them, and for the second one is for the sake of just getting the red votes. Okay. If we revisit the query again before we finish it, we say for each red vote, we want to find the number of reservations for this vote. Okay. So far if you look at here, the evaluation process is like this. we first take a cross product between the both and the reserves, right? And then each tuple in the cross product will be checked on whether they qualify based on the qualification. Okay, so unwanted tuples are gone. Then we select. Then unnecessary fields are deleted. Okay, tossed away. And now we want to group them. So what should we group by? Because after this step, we actually already don't have any boats with other colors and boats that are not reserved. Correct? Before we group anything, these are already handled. So all we need to do is to have a group by PID. Okay, just group by the boats.
Just select the PID and the
Say it again. Select the BID.
Yeah.
Oh. I selected because I just want the generated table later to have a column of the BID.
But it is the column can give you the BID and why would you duplicate it?
It's only gonna give me.
The BID can count on that.
So why would I what?
Why would you duplicate it? There's no other.
Oh, if you don't put this.
I mean, since you already have the BID and number selected, I just don't see why you should still group it by the BID.
No, if you don't group it, you will actually have them all separate, so they won't aggregate it.
What do you mean by separate?
Let's try it.
Oh, I see.
Okay.
Since
So they
there's
like
multiple- there's
they
multiple-
can't distinguish the difference. Yeah, so it counts them all. So if you take a look back at here, we don't do group by. It just count like we did before, counting how many sailors are in there, right?
Okay.
So it just basically count them all. And the reason it gives BID is just because that's the first one. Okay, so that's why we do group by. That's a good question. Yeah, so that's the difference between these two. Okay, without grouping, it sums them together, right? Like here. With grouping, we separate them. All right, so before we move on, not just yet, I want to talk about a wrong way of doing this, okay? So for query 33, there is one way that will actually be wrong. All right, so earlier we were talking about the having clause. So having is actually doing qualification on the groups instead of just each tuple, right? So let's say today we got confused and we thought about having, we can just apply it on the tuples. Then you do having color is equal to red, and we get rid of here. Okay? Some sense it seems legit, right? You read through it, so that looks right. You can try it out. So they actually give you error. So for this kind of qualification, it's not allowed in SQL, because if you look at it, after it's being grouped by, you say having the color equals to red. It doesn't know which color out of the tuples in the group that you're referring to. Okay? So you can't do that. Okay, so that's for query 33. Let's take a look at query 34. So this has a very subtle difference compared to, I think that's query 32. Okay, so in query 34, we want to find the average age of sailors for each rating level that has at least 2 sailors. Okay, I'll get rid of all these. So for this, it's saying when you want to find each rating level that has at least 2 sailors, Oh, no. Forget about what I was saying. No, just think about what you would do for this one. So what would you do to find the average age of sellers for each rating level that has at least 2 sellers? You need to select. Think about whether you will use where or having.
For the previous one, if you had in the first line select, if you had v.color, then you get the correct answer.
Oh,
Since we didn't have v.color in the first line, so it can't group it based on color. And you had the having color.
you say here.
Yeah.
Do we keep the ID?
Yeah, that should be good.
Oh. Let me see. Oh, okay, I see. So that's because when you're checking the having, so after here, because we include the color information, so it means each group has the color, the having has something to qualify. Huh? Yeah, that's good. All right, so what would you guys do for 34? Would you use where or having? Having. Okay. So let's see, what would you do? We want to select the average age of sellers for each rating level. So we can get the rating first, since we're going to group by it anyway, right? And the average age of it. Okay, then from the sellers, and group by what?
Right.
Rating. And having what?
Count. Better than
So you can count. Here I count the SID, okay? Then two. That would do. Okay, so here's the difference between having and where. We use having to say we want to check on a whole group. All right, that's for that. Any question on this one?
Is there a difference if you use star instead of SW?
For this one, no, because counting SID is the same. So actually, in here, it doesn't make a big difference because we are not doing any distinct. So in SQL, if you have duplicates, it still count the duplicates. Okay, so sometimes we will do, maybe we want to find a unique name, then we will do distinct S name. Right? So it doesn't make much difference. Any other questions for this one? Okay, move on. Let's do query 35. I think I'll work on 2 more, then we can do the quiz, okay? And for the rest that doesn't finish, sure you guys can figure it out, and I'll post the queries as well, because they're just very similar. So let's take a look at query 35, where we want to find the average age of sellers who are older than 18 years old for each rating level that has at least 2 sellers. select them from is definitely required. Do we need where for this one? If we have find the average age of sellers who are older than 18 years old. All right, so we need that because we see those who are older than 18 years old. And because we want information for each rating level, that tells us we will need group. Okay. And because here we say for each rating level that has at least 2 sailors, that tells us that's a qualification on the groups. So we will need half. Okay, we need them all. And let's start working from the top of it. So the things we want are the average age of sailors for each rating level. So we can take the rating level and the average age. Okay, so these two are simple. Those are just the columns we want. And again, right here, we are only dealing with the rating level and the age, so we don't need information from the boats or reserves. We only need from sailors. Okay. And also, when we read the query, we see that we want only information from the sailors who are older than 18 years old. So we just need to do this. Right? And because we want that for each rating level, so that's what we will group by. It's also simple right here. But how about right here, where we say for each rating level that has at least 2 sailors? Can I directly say this? Can I do that? Do you think this will give us the right answer? If we rethink about the evaluation process, until here, we get all of the sailors that are greater than 18 years old, right? And then we do group by. So if here we simply count the SID, we have the count SID greater or equal to 2, that means you already count the ones that are older than 18 years old, right? But if you look at the query again, it's just basically saying for each rating level that has at least 2 sailors, regardless of their age. Okay? So here we actually cannot do this, but we will want to count the number of sailors in each rating, again, without using things. So what would we do? We can actually do this. Okay, we have 2 less than or equal to, and then we open up a whole nested query for that. So here what we can do is we will, because they're having, it will check on each group. So what you can do is by simply doing this. We do select, and we just count the number of sailors from a new sailors table, we say S2, where S2 rating is equal to BS. Okay. So right here it makes sense because after select from where, we group by the rating, and then for each rating group, it will do, again, the inner query. Okay? And so it will have a corresponding rating, and then each time it will check the total number of the sailors in that rating. Okay. So this is this tiny difference whether you can use having or not. Because if we use having, we get rid of the sailors that are not older than 18 years old. Yeah?
I have a kind of a irrelevant question. Why did you use greater than or equal to 18 rather than use 2?
Oh, yeah, that's just my understanding, but is older than, like strictly greater than? I don't know. What do you guys think? Yeah, we can change it. It doesn't matter, yes. Thank you. Any question on this one? No more? Ready? Okay. Okay, there was. No? Come on. So if you're done, you can just come up and give it to me, and then that'll be it for today.